It's been a week since the historic lake effect snow that brought more than 5 feet to a narrow swath south of Buffalo. But a few aspects of that event really deserve to be highlighted. Now, the catalyst for major lake effect snow is well known. Frigid Arctic air heated and moistened as it flows over relatively warm lake water, a situation most common in late autumn. Now, the word unstable is way overused in meteorology, but it really applies here. Atmospheric instability depends on how quickly the temperature of the air decreases as you go up. Formally, that cooling rate has to exceed 5.5 degrees per 1,000 feet to be unstable. Now, I'll spare you the details of where that number comes from, but if that happens in a thick enough layer, you can get really tall convective clouds. Now, last Tuesday, much of Lake Erie was around 50 degrees, while the temperature about 3,500 feet above the lake was all the way down to 0. We'll do the math for you. That's a cooling rate of about 14 degrees per 1,000 feet. Extreme instability that favored plenty of fast rising air in the lower atmosphere. And indeed, visible satellite imagery last Tuesday showed lots of texture in the cloud band. That popcorny structure, a sure sign of embedded convection. In fact, some thunder snow was reported as snow accumulated 4 to 5 inches per hour at times. Last winter, researchers used the Doppler on wheels to study lake effect snow bands up close. Its high-resolution radar imagery confirmed that these bands sometimes have small-scale structure that resembles what you see in severe thunderstorms. Here's a 10-hour radar loop last Tuesday, a time when the band of heavy snow was basically locked in place, like a fire hose pointed just south of Buffalo. Low-level west-southwest winds blew parallel to the longest length of Lake Erie over more than 200 miles of open water. The edge of the heavy snow band was very distinct, a surreal wall of snow that moved very little most of the day. And that sharp edge to the snow band led to remarkable snowfall differences over very short distances. Here's a close-up of some snowfall reports from last Monday through Wednesday. The zone that got 3 feet or more was only about 15 miles wide. But check this out. You see that 63 and that nearby 6? Those places are just 4 miles apart. Think about that, a 57-inch snowfall difference in 4 miles. If you're familiar with State College, 4 miles is the distance from the Nittany Mall to the Nittany Lion Inn. Now, the stubbornness of the heavy snow band and where it's set up was helped by the local winds. Here's some surface wind observations near Lake Erie during the heavy snow. If I use the winds right next to the lake to overlay some arrows, you see a narrow zone where the winds were coming together or converging, and that's where air tends to rise the most. This feature even has a name, a locked thermal convergence zone. It just about pinpointed where the band of heaviest snow set up on land south of Buffalo. Fred will let us know if any lake effect snow is in our future in the extended forecast next.